The distance between any two vertical lines, the stick lines, this will be 1 centimeter. Similarly, the distance between vertical lines, you can pick up a graph paper of any scale, nothing. So just the typical graph paper, what you come across in high school is what I'm just presenting here now. Why do the graphs we have to, first topic, why we have picked up this one only. So what is basically a graph means? So graph, what it does, it gives the diagrammatic representation of two quantities. Many quantities, so of two quantities, it will give the diagrammatic representation of the two given quantities here. Diagrammatic representation means like, sir, we are not understanding anything. So we can start like this. So suppose say like a y equal to x. What is y? So what is y? Y can be, I think we are in now pandemic. So this is like a number of COVID infections. This is the y. Then this is like a breaking up of COVID norms. How these two are related? These two are linearly related. As we break up, as the population, so there's like a population, we'll write it. As the population, as the people break up the COVID norms, the number of COVID infections will increase. That's what we can say that one. So how do like this is one mathematically. Number of COVID infections is equal to population. So how do we write first language? In language, how do we represent? As population now, so the in terms of language, no, number of COVID infection increases as population breaks up COVID norms. Okay, this is what I'm. There's a language, no. So the first one is what literally you are expressing using the words. Second one, mathematically, y equal to x. This is the mathematically. If you are good in, if you are good idea of the English language, okay, you may understand this particular sentence. Means as the more number of people break COVID norms, so the number of infections will increase. So you should have a good idea of the language. This you should be very good in maths. What is y? Y means number of COVID infections. What is x? X is a mathematical. Okay, this is the y. This is the x. X is the population breaking up of COVID norms. Now, still some will find very difficult to understand. So here we bring the help of a graph. So in the graph, what we do is like it will be very easy to express these things. So I will pick up no, not visible. Let me choose thick line. Yeah. Okay, I think you are with it's visible. So I'll just put y and x. And I can show that initially, okay, the graph was like this. What does it mean? It was increasing linearly. It was increasing the linearly. Let me show that linear. It was increasing linearly. Sometimes it may increase exponentially. You can see, like, I think the rise is very steep, no? Or it may increase gradually. I think there are different ways are there, no, in expressing that one. So this particular curve we say linear. This is exponential. This is like some parabolic. Some rough some names are giving for the shape of curve. So if it were linear, I'll write like this. So that then if it for the red color, so what is the equation for this? Y equal to e to power of x. The equation for it, y equal to x. The equation for this, y equal to x squared. So now what is the first one? So these are the ways. These are the literal language. There's a mathematical. Third one is what you can see graphical. The red curve, how you write literally number of COVID infections are increasing exponentially. You see this green one, what you say, number of COVID infections are increasing linearly. Number of COVID infections with population breaking norms are increasing parabolically. So that literally you're going to write here. Mathematically, you're going to just say that y equal to e to power of x. So this is the thing. So now that all three curves, let me just show it. How we interpret, like first one, the red color, number of COVID infections are increasing exponentially due to breaking up of norms by people, will write it. This is the first. What about the green color one? Green color one, the literal language, how do we express is linearly increasing linearly. Similarly, the other curve parabolically. I think these are the things what we who will understand this language. Very difficult, no? Probably you should be very good in English, everything. So what is the first method? Language. Expressing the relationship between a quantities using literature, or better you say like using through sentence. I'm putting it. There's a language. Second, what you see graphically. Third one is what you can see the equations. I wrote equations. So the first one is y equal to e to power of x. Second one is y equal to x. Third one is y equal to x squared. So this is the mathematical. I'll write it here. Okay, now you have everything information. Definitely, I'll ask you which one you will give a better picture. If you read like this, will it flashes for you anything? No. If you see the equation, no. But when you look at graph, you feel S. Okay, this if it varies like this exponentially. So this will give a better picture, no, for us, the relation between Y and X, relation between the number of COVID infections and the population picking up of COVID norms. Means, what about this? This will be, though the population is breaking up COVID norms, the infections are, number of COVID infections are less. It's not increasing like steadily, or you can say it's not increasing very steeply, that one. So that's what you can say here. If the curve is like this, as how much you break up, those many infections will come. What about here? Even if 1% breaks up, 10% will get infected. This what thing. So I think this curves, what happened, this picture information will give us a more information. Initially, the pandemic will be like this. And the pandemic is at peak, it will be off like this. 1% breaks up and it will infect 10 persons. 100% breakup, the infection will be 10 initially. So these are the ways in which what happen, the graphs becomes very important. So now I think you can see that the data, so this will be more easy to represent the data. It gives the diagrammatic representation of two quantities, or the data you can call. two quantities or terms or anything that will be. Not only this pandemic, you can pick up anything. Even your day-to-day life also, you can express yourself graphically. Say like, now what about the sleep? How you sleep, that one? Huh? So like after 8 o'clock also, if you start using mobile, the amount of sleep definitely will be less. So you can also plot your activity with various other things. So the graph is something very, very important, which will give us a very good diagrammatic representation of two quantities. That's why the graphs are very, very important in physics. So there's a primary idea of the graphs. Everything. So now our focus is like, we'll try to learn. Almost in physics, you can see every chapter, every topic, you do come across the graphs. Every topic you do come across a graph. Let's go for the thing which we are supposed to learn mathematically. First, let me start with y equal to x. How to plot that y equal to x, and we also determine the slope of that given curve. So if you look at the So first, like a equation of straight line. So what is a straight line? Straight line is what you are seeing here. First, we are going to begin with the topic equation of a straight line. So there's a linear equation. So y equal to x. How to plot the graph for that particular equation. So what is the method we have to follow here? What is the method in plotting graphs? So first, what happened? Don't bother graph left hand side. Now look at the column y equal to x. For you can start like x equal to 0, 1, 2, 3, 4, 5, 6. Then corresponding value of y you find out. Definitely x equal to 0, y will be 0. X equal to 1, y will be 1. X equal to y equal to 2. You'll get this one. Then looking at this value, what is the least value? 0. What is the maximum value? 6. Similarly, y also. So I think there's a graph, 1 unit, I'll take 1 centimeter. So this will be 1, 2. So this is our original define. 1, 2, 3, 4, 5, 6, 7, 8. This is the x-axis. This is a y-axis in centimeter. This is the y-axis. Y-axis also defines 0. This will be, I think the graph, little bit position. I'll adjust it. Okay, I just checked, no? No, come for this one. Okay, this is the x equal, y equal to 0, 1, 2, 3, 4, 5, 6. You have a terms like this. Then this is the curve. So curve, or better say like the response, y equal to x, what we are plotting. So how do this particular curve has come? How does this particular curve has come? So directly for x equal to 0, y will be 0. X equal to 1, y will be 1. Look at the red dot, experimental dot. Put x equal to 2, y will be 2. X equal to 3, y will be 3. X equal to 4, y will be 4. X equal to 5, y will be 5. X equal to 6, y will be 6. Then I'll join that all that red dots. Sir, how you join? Take scale. Take scale. So can you join all that experiment points? So I got a straight line. So this is what the graph is. Able to make it out? How to plot a graph? You need 5 experimental points. Minimum you need 5. And anyway, I took here some 7 something I took it, but minimum 5 is sufficient to get an approximate graph. Exact graph, you have to choose more number of points. So this is the expression for equation of a straight line. Now, here only I'll introduce the idea of the slope. So this particular straight line, it will make some angle with x-axis, and you know the protractor. So when you go for the protractor, let me introduce the idea of the protractor. Or else I'll draw it. So when you take the protractor, these are some various lines, all of you protractor. So you can take help of geometrical instruments to measure that angle readily. So this will be defined as 0 degrees. This will be defined as plus 90, and this is defined as 180. How do we measure that angle? So if you take the coordinate system, rectangular coordinate system, so angle, if you measure in this angle, so let me shade this angle. So this angle, what it should be? It is taken as positive, no? So that you can notice here. So if you have a straight line, which will make, so this angle measurement is taken as positive. And how do we measure this one? So from the x-axis, so because this is 0-degree line, and this particular straight line now will make an angle theta with 0-degree line. And this is 90-degree. This is 180. This will be 270. Counterclockwise angular measurement is taken as positive. Then what about the negative? So there should be a -1. So if you take the so let this be a straight line which will subtend an angle. Here is what that theta. I'm showing some big so that will be easy for you. Look at the theta, how it is measured in opposite sense, and this is theta equal to 0-degree line. This will become -90. This will become 180, -180, and this will become -270 degrees. So now this angle is to be taken as negative. This angle theta will be taken as positive. I think already you know protractor. So this, if you keep the protractor there, it will lead some angle, no? And 0, and it will be, maybe this third line will merge, maybe it is around 45 degrees, and you say this 45 degrees. If you keep protractor inverted here, and you start measuring in clockwise sense, it will be negative. So then, so what is the convention? Counterclockwise angular measurement, counterclockwise angular measurement should be taken positive. Clockwise angular measurement should be taken as negative. We will write it here. Counterclockwise angular measurement is positive. Clockwise angular measurement is negative. So look at this now. What is the angle? This straight line. You bring this protractor. It's a protractor, I think. Open just geometry box. You see that protractor, and keep it in your notebook. Draw this particular line y equal to x. Keep protractor there, and the protractor will read 45 degrees. And this angle, what I should take? This should be 45 degrees plus 45. Sir, why plus 45? Why not minus 45? Counterclockwise, opposite to clock. I think in the, if you look at the clock, the hour hand, minute hand, second hand, how do they rotate? They're rotating clockwise, no? So here the arrow, we are going to measure that angle opposite to the clockwise rotation. So therefore this is called a counterclockwise. They should be taken as positive. So this angle will be 45 degrees. So it is making an angle of 45 degree with x-axis. This particular straight line is making an angle of 45 degree with x-axis. Or we can also say that how steep it is. The word steep. Sir, what do you mean by steep? Like the steepness of the ramp. I think in nearby your home, you can see the ramp. So it should be steep or should be very less steep. It should be less steep, no? If you're very steep, you cannot climb. So the meaning of steep, suppose if you have okay, there's for a vertical wall and you have placed a ladder. Now, in which case the ladder will make more angle with ground. So this will be ground. So here you are going to right angle, say like a 60 degrees. This will be say 15 degrees. Where you can climb this ladder very easily. Definitely this person, what will say? It is more steeper, no? You'll say that one. This is less steeper. So it will make less angle. So this will be more steeper. The ladder is having, the ladder is more steeper here, we say. The ladder is less steeper. There's a common language, the steep, like a steepness, something. So here we'll call that as a slope. So how much the like a slope, tan 60 is what the slope is, or how much the angle the ladder makes 60 degrees, here 15 degrees. Then we'll calculate the mathematical, we'll call tan 60 as a slope. The measure of the steepness is nothing but we can call it a slope here. The slope is what I wanted to express. How we define slope? Delta y by delta x. And delta y, what do you mean by delta y? Change, final minus initial. Change in y by change in x. So delta represents change. What delta? Delta represents change. So change in y by change in x. The ratio of that is what? We should take that as a slope here. Okay, now let's go for slope, calculation of slope. For that, let me take the corresponding. So I'll choose 2 points. You can pick up anything. So for these are the 2 experimental points we have picked up. Now I'm just shading that part which is very much needed for us. Okay, see this, some triangle is what you are seeing this one. I'm choosing 2 values, one, x1, corresponding to that, this will be y1. I'll choose another point x2 equal to 5, corresponding to that as y2, and this will be delta y. And this distance is what I'll call delta x, and that I'll represent here. This I don't know, let me calculate. This is x-axis will become theta equals 0 degree. Already I'm showing here. Look at this one. So now this straight line, it is making some inclination with horizontal. So this angle, how much it should be? It should be theta only, the same, this theta. Then, so this will become like opposite. This will be adjacent. So how we define slope? Slope as change in y by change in x. So this will be change y2 minus y1 by x2 minus x1. What is value of y2? 5. Okay, this y2 is here. Corresponding x2 is here. This is y1, this is x1. So we'll just indicate. We'll mark those points where we have picked up. Are you noticing? No? This is what you can write 5 minus 3. Look at here. What is y2? Means like for x1, when x1 equal to 3, what is corresponding value of y? 3. When x equal to 5, what is the corresponding value of y? 5. Those things I put it. So 5 minus 3 by, this will be 5 minus 3. So this will be 2 by 2. This is 1. I got slope equal to 1. Literally, and we have other side. What is tan theta? So delta y by delta x is equal to 1. No? So we define tan theta as delta y by delta x. So what is the value of this? Equal to 1. If tan theta equal to 1, theta equal to tan inverse of 1, which is equal to pi by 4. This in radian, or in degrees, it will be 45 degrees. You take calculator and measure it. It will read 45 degrees. The straight line will make 45 degrees. So what we have done, there are two things are there. You can take help of, it's an instrument. It's an instrument. It's a geometrical instrument. So you can take help of geometrical instrument to measure the angle made by a given straight line. Are you getting now? So just bring this protractor to read 45 degrees. If you don't have that instrument, can you solve this by analytically? Can you find out this analytically? That the answer is yes. So for that, what we are going to do is like, just define. So choose 2 points. Choose 2 points on a curve, or so on an experimental curve, or on this particular straight line. Then drop a perpendicular onto the x-axis. Those two perpendiculars will meet the x-axis at points x1 and x2. What are the values? x1 equal 3, x2 equal 5. Corresponding to these points, locate the values of y. So here what happened? Draw an horizontal line. So that horizontal line will cut the y-axis here at 3 and 5. Then y2 minus y1 by x2 minus x1 will be the slope. This is from geometrical method. This is from from protractor. If you know protractor, what you should do? If you know protractor, what you should do? Measure theta. Tan of that theta will give the slope. So therefore here, if you want to find out a slope at any point on a curve, so draw a tangent at that particular point on a curve, then find out the tan of that particular angle made by the tangent at that particular point. That is nothing but equal to slope. Very, very important. The very first chapter, so like a third chapter kinematics, we do start with this idea of slope only. So it's very essential for us. What do we got this slope? Positive, no? So what does it mean? As x increases, y will increase. The positive slope, what is the meaning of that? As x increases, y will increase. That's the meaning of positive slope here. So here, like this is what we define here. Okay, what is nothing but slope in terms of literal? The steepness, the measure of steepness of a curve. How steep this particular line is there. So that okay, we'll take the. Now I'm bringing another. I try to look at only this upper part of the thing. There are two straight lines I drew. One blue color straight line is B, and the red color straight line is A. The two lines I drew. So what about their slopes is what I'm asking. Can we calculate their slopes? So there's a blue color line. Okay, there's the first slope. First we'll go for straight line here, and look at the x like a axis. What we have. We have here one for every 1 unit equal to 1 centimeter. So 1, 2, 3, 4, 5, 6, 7, 8. Okay, we have marked it. Similarly here, 2, 4, 6, 8, 10, 12. Like that on y-axis, 1 unit equal to 2 centimeter. We have marked it. Okay, directly I'm giving a curve. I'm not giving any equation. So can we measure the slopes of this? So you do one thing, bring this protractor, keep it here. Then this blue color line, on which line of the protractor it will merge. Then corresponding to that, note down that degree and that angle when you measure, no, that will be the theta B. Similarly, keep the protractor, this O or this particular reference dot, let it be at origin. Then this red color line will merge with one of the line marked in the protractor, and note down that angle from here to here. Note down that angle. So when you, I think this. The red color line will merge with one of the line on the protractor. So measure that angle, theta A. The blue color line will merge with one of the line on the protractor. That will be theta B. And tan of theta A will be the slope. This is using protractor. Now without protractor, how to do is what we are trying to learn. Without protractor, what to do? Then how to calculate the slope? Tan of slope of this straight line A. You measure the angle theta A from the protractor, then tan of that angle should be the slope of the straight line A. Similarly, the slope of straight line B, using protractor, measure that angle theta B, then tan of that theta B should be the slope of straight line B. That is using geometrical instrument. Okay, from using geometry or from the diagram what we have. Can we calculate here only in the graph paper? Yes. So corresponding to on the straight line A, I locate 2 points. So these are the 2 points which I picked up. Any 2 points, you can pick up this points and I'll pick up 2 points. So corresponding to this point, what is the value of x? X1, 3 it is. Corresponding to this, what is the value of x? It is 5, that I'll indicate x2. Then corresponding to this particular point, what is the value of y? That is y1, 6. Corresponding to this point, the corresponding value is y2. that is 10. Okay, then how we define slope? Delta y by delta x. So y2 minus y1, delta y by delta x is what I wrote it here. Tan theta equal delta y by delta x. So tan theta A should be equal to y2 minus y1 by x2 minus x1. What is value of y2? 10. Y1 is 6. What is x2? 5. X1 is 3. So 10 minus 8 by 5 minus 3. And what do we get here? 4 by 2. Tan theta A is 2, or nothing but the slope of straight line A is 2. How much angle theta A? 63.43 degrees. So how do you get it? Take calculator. Tan inverse of 2, how much it will be? So tan theta A, I'll write it clearly. Okay, there's an angle made by the straight line A with x-axis or with the horizontal. Or what is the slope of straight line A? It is 2. I think you make observation. This is what we have concluded. Tan theta A, or you can also call it a slope. I will write here. Some of you are asking. No. Come for next part of the thing. For the straight line B, again, I'll choose 2 points on a straight line. So what are the 2 points? The 2 points are here. I'm marking black color. No. Now look at these 2 points. These 2 points. So corresponding to that point, okay, look at the value of x1. So it will, if you drop a perpendicular, it will intersect the x-axis at x1 dash. Then simply at the other point, drop a normal, it will intersect the x-axis at a point called as x2 dash. And you can see here, it will intersect, if you draw an horizontal line, it will intersect the y-axis at y1 dash. And from point B, from here, this second point, it will intersect the y-axis at y2 dash. So the corresponding values are y2 dash, y1 dash, x1 dash, x2 dash. Then here the tan theta B is what, again, the definition what says delta y by that. This is what delta y dash. This is delta x dash. So y2 dash minus y1 dash. So values of those things will substitute 8 minus 4. So 4 by 4. So this is equal to 1 we are getting. So what is the slope of both the curves? Slope of both the curves are positive. How much I'm getting slope? Slope is equal to 1. So slope of A is how much? Sorry, the slope of B. So what does it mean? The B makes an angle 45 degrees. Afterwards, what you should do? Tan theta B is equal to 1. What is the answer we got? Theta B equal to tan inverse of 1. So what is the tan inverse of 1? Should be pi by 4 or 45 degrees. Anything you can write it. Or 45 degrees. So how much of this straight line will make an angle with horizontal? 45 degrees. So this is the graphical method. Sir, who will do all this? I'll take protractor. Okay, carry on. Very easy. So again, once again, what do you mean by positive slope? as x increases, y will increase. You can see that x equal to 1. What is the value of y? 2. For red color straight line, x equal to 2, y will be 4. So slope positive means what does it mean? As x increases, y also increases. There's the meaning of positive slope. Don't get confused with this one. Slope means tan theta. Theta is the angle made by the straight line with the horizontal axis. Slope means tan of that angle theta. Okay, like this, I think I slowly introduced to the idea of a slope here. So now we'll take the next condition. I brought another. Now look at this part. Y equal to x plus 2. This is our experimental curve. Y is equal to x plus 2 it is. Then first what happened, we have to plot this particular curve. Already I have pre-written, because again, scribbling and explaining, it will take more time. In less time, we can conclude more things. So y equal to x plus 2. There's a one equation. We have to first plot the curve. I start from x equal to 0, 1, 2, 3, 4, 5. I'll get the corresponding values of y. Put x equal to 0, y will be 2. Put x equal to 1, y will be 3. X equal to 2, y will be 4. X equal to 3, y will be 5. I got the corresponding values of y. Look at the tabular column for x, 0 to 5. Tabular column for y. It will start, the lowest is 2 and the minimum maximum is 7. So I'll assume 1, 2, 3, 4, 5, 0. We'll let 1 unit equal to 1 centimeter, both for x and y axis. Then I look at the experimental dots. This will be, so the curve will be first x equal to 0, y will be 2. X equal to 1, y will be 3. X equal to 2, y will be 4. X equal to 3, y will be 5. X equal to 4, y will be 6. X equal to 5, y will be 7. Then what you should do, join all those experimental points with a straight line. So this is the equation, this is a straight line, this is a curve. Okay, this is called like an intercept, y-intercept, because it is intersecting the y-axis at a point, 2 centimeters. Now we are more interested in now getting the slope here. First, can we calculate angle made by the straight line with horizontal? So whose help we have to take? Take protractor, keep it in this position, such that tan theta, you measure theta, then tan of the theta will be the slope, that one. Then if you want to calculate theta, just take the protractor. So now I'm interested to measure the slope. Again, first, what is the slope? Slope should be equal to tan theta, and tan theta is what? Opposite by adjacent, delta y by delta x. So I'll choose 2 points on a curve. Corresponding to those 2 points, I'll locate x1 and x2, y1 and y2. I think I'm showing it clearly here. Now, corresponding to this point, what is y2? 5. We are writing 5. Corresponding to this point, what is y1 value? 3, 3. Corresponding to this point, the x1 is 1, x2 is 3. So all this, we are getting plus 1. So what is the slope of this straight line? It is 1. That 1 is what is indicated here. Slowly, I'll introduce to the idea of the slope here. The 1 is what indicated here. And this is like an intercept. So what is the slope of this straight line? It is 1. How much of angle it will make with horizontal? 45 degrees. So the reason for that, because tan theta, we are getting 1. Tan inverse of 1. So this will be pi by 4 radians, or degrees, it will be 45 degrees. So the angle made by the straight line with horizontal will be 45 degrees. So now slowly, sir, what is the quotient of x? It is 1 here. So I'll call the slope is 1. And this is called like an intercept. We take the next one. So little bit, the idea of slope and intercept is what I'm trying to bring. Now we have equation y equal to 2x plus 3. First we'll plot the curve. After plotting the curve, then what do you mean by slope? How much of angle it will make with the x-axis, all that we'll try to determine. So now first x equal to 0, you will first will have a tabular column. X equal to 0, y will be 3. Then x equal to 1, y will be 5. X equal to 2. So for these are the corresponding values of y for x equal to 0, 1, 2, 3, 4. Put x equal to 3, y will be 9. Put x equal to 4, y will be 11. Put x equal to 5, y will be 13. So I got the values for different values of x I got. Now come for this one. Look at the curve one. Look at the tabular column. X varies from 0, 1, 2, 3, 4, 5. What about the y? Y will be 3, 5, 7, 9, 11. So the scale little bit will be different. For x-axis, 1 unit, 1 centimeter. For y-axis, 1 unit will be 3 centimeter. So all this x and y, let me measure in terms of centimeters. So therefore, 1 unit will be 3 centimeter for y-axis. The scale always need not be equal. It all depends upon the values. 3, 6, 9, 12, 15. To accommodate the curve, or else you can also do one thing, 1, 2, 3, 4. It will become very long, the graph. So to accommodate in a smaller space, we can choose the different scales on x and y axis. So got it, no? So this is about the first difference. So after this, what we should do? We should go for plotting of graphs here. So how to plot the graph? Again, what is the method? First, you have to go for the experimental points. So what are the experimental points here? The experimental points are put x equal to 0, y will be 3. Put x equal to 1, y will be 5. The 5 is approximately, I'm just locating here. Put x equal to 2, y will be 7. Put x equal to 3, y will be 9. Put x equal to 4, y will be 11. Put x equal to 5, y will be 13. Join all those experimental points, that 5 or 6 points were there by a straight line. Then we have to calculate a slope. So for that, what we are going to do is like, I will choose 2 points. You can choose any 2 points. So let me just pick up some arbitrary points is what I picked up here. These are the 2 points what I picked up. So this corresponding to this is what x1. And corresponding to this is what this x2. So what is x2? X2 is 3 and x1 is 1.5. x1 is 1.5. Then corresponding to this point, what is value of y? 9 and this is 6. So let me define how you define the tan theta. Delta y by delta x opposite by adjacent. So this will be 9 minus 6 by 3 minus 1.5. So solving this will get 2. So this is the slope is what I should call. So what we have calculated? We have calculated slope. Slope, what you write delta y by delta x only. So when you solved it, how much you got? Plus 2. Then what is the equation of straight line? This is what we write, y equal to mx plus c, and this is what we write, m. What is the symbol for mathematical symbol writing? Every time writing slope will be inconvenient, so we just write m. And every time writing that intercept, instead of writing intercept, we just write c. No, in place of, so what is the slope? We calculated 2, no? So therefore, in the equation of straight line, what do this coefficient of x will indicate? This will indicate slope. And what is this? This will indicate the intercept. So that's what we are finally, this will indicate, and this will be intercept. Which intercept? Y intercept. I'll just, let me write only y intercept only, let me call it. So what is the equation of straight line? We do write y equal to mx plus c. What do that m? M will indicate slope. What do you mean by that again? Again and again, what do you mean by that? Tan of how much of angle that particular straight line makes with x-axis. That's the meaning of slope. What is the slope? How you define? Tan of how much of angle the straight line makes with horizontal is what we define slope. Mathematically, delta y by delta x. So how to measure theta? How to measure slope? There are 2 ways. There. One, graphical is what I'm showing. Other is take protractor, measure theta, tan theta will be the slope. Fine. That's the simplest thing. So look at this particular straight line again. Is it having positive slope or negative slope? As it's having a positive slope. You look at the intercept of the coefficient of x plus 2. And now again here, as x increases, y increases. No, you look at the column here. As the value of x increases, the corresponding value of y also increases. So for a positive slope, if a curve or a straight line is having a positive slope, what does it interpret? What it will interpret? As x increases, y will increase. Very important observation. Very, very, very important. And then similarly, we'll take the next one. I'm bringing the y equal to minus 2x plus 3. I wrote equation y equal to minus 2x plus 3. Let's see, let's not get scared looking at all. I'll explain all one by one in order. So this equation, what we have, y equal to minus 2x plus 3. First, we'll choose the values of x. X equals 0, 1, 2, 3, 4, 5, 6. The corresponding values of y is what I'm getting of this nature. Put x equals 0, y will be 6. Put x equal to 1, y will be 4. Put x equal to 2, y will be 2. Put x equal to 3, y will be 0. Put x equal to 4, y will be minus 2. Put x equal to 5, minus 4. Put x equal to 6, it will be minus 6. These are the corresponding values of y. Okay, now come for this scale. Look at the values of x, 0, 1, 2, 3, 4, 5. So for 1 unit, 1 centimeter. What about y? Y, what happened? Here we have 6 and minus 6 are there. So therefore, 1 unit, let it be 2 centimeter. 1 unit, let it be 2 centimeter. So 0, 0, 2, 4, 6, 8. Like that, you choose a scale. Then we have to look at the points. X equal to 0. The value of y will start with 6. So here's 6. Put x equal to 1. Y will be 4. Put x equal to y will be 2. Put x equal to 3. Y will be 0. X equal to 4 minus 2. X equal to 5 minus 4. X equal to 6 minus 6. Join all those red dots. They're experimental points. You'll get a straight line. Look at the curve. It's different than the curves other we have seen. Okay, now you bring the protractor. That either you are going to say this is the theta or this angle. This theta you measure counterclockwise. What about this alpha? This will be clockwise. Let me define this alpha. I know this angle I'm measuring in opposite sense. Keep in mind here. So now here I'll define this theta. Are you seeing this? This is our straight line. This was that experimental thing. So these are the dots. I'm not drawing for. When you keep protractor, it will be like this. So you're going to measure that alpha in this way. Let me define that alpha here. So what is alpha? Angle measured by the protractor. Angle made by the straight line with respect to horizontal. If you have directly geometrical protractor, protractor is there. So measure alpha, tan alpha, there'll be the slope. Able to understand? So this will be very simplified one. Measure alpha, tan, take calculator and or the log table, tan of that angle. That should be the slope here. Otherwise, so can you show graphically? Yes, I'll choose 2 points. These are the 2 points. Let me denote A and B's. Corresponding to A. So what is this? What is value of x? Will be x1 equal to 2. What are those experimental points? The experimental points are here. Then what is the corresponding value of y? Will be 2. So when for A, what happened? The value of x will be 2, and the corresponding value of y will be 2. Then I'll choose another point B. Or the corresponding value of x will be 5. The corresponding value of y will be minus 4. Here, you have to look at this part. Huh? I'll indicate, I'm just highlighting it. At least hope you are able to. See this x1 equal to. Okay, how you define tan alpha? opposite by adjacent delta y by delta x. Delta y by delta x. So I substitute delta y means what? Final minus initial. Delta means change. Change means final minus initial. Always it should be. Now what is value of y2? Minus 4. Substitute with sign. y1 plus 2. x2 plus 5. x1 plus 2. Solve this, you'll get minus 6 by 3 minus 2. Tan alpha equal to minus 2. What does it mean? The slope is negative, you're going to see. The slope of this curve will be negative. So what is the slope of this curve? Is equal to minus 2. So what is the value of slope? Slope, you're going to write it as or select a, sir, what about theta? You know alpha plus theta should be equal to 180. Then when you measure theta, how much you'll get? It'll become 116.656 degrees. So definitely, can we define now straight line having positive and negative slope? Straight lines, those are having negative slope. As x increases, the value of y will decrease. The straight line is having a negative slope. As x increases, the y will decrease. That's what you can see. As x increases, the value of corresponding value of y decreases. Positive slope, we have discussion. Positive slope. As x increases, y will increase. Are you noticing this? I'm asking you, look at these two columns. As x increases, y increases for positive slope. For negative slope curve, as x increases, the value of y will decrease. You can see this one. This is what happens here. So what is the slope of this straight line? It will be negative. Sir, how you differentiate? Okay, there's one method is what I'm showing. As x increases, y will decrease. There's a thing. Or else here the straight line will make an angle how much more than 90. So what is the slope? Should be definitely negative. That's what, no? So here with respect to positive x-axis, if you see this one, this angle is how much? More than 90. Slope should be negative. Or you are going to measure this angle in clockwise sense. So this angle is negative. So therefore slope will be negative. Slope of this straight line is how much? Minus 2 it is. Once again here, trying to explain that basic idea. So this minus 2 indicates a slope. This 6 will indicate the intercept. Because there everything is clubbed here, so you can see clearly. So is there any, like what is this minus 2 is called as a slope. And what is this 6? 6 is will become intercept. Slope of a straight line, and this is intercept. Sir, I'm not understanding. See, like you should have very generalized idea. Very generalized idea means, let me save the content. We were here, no? Let me search the where is it? Yeah. Y equal to 2x plus 3. This is okay. Let me. So we are, you can select definitely, sir, we are not understanding a little bit that positive and negative slope. You directly take the wall, if you have a wall. There's a wall. And there's another wall.